Hi class. In this lecture here, what we're going to do is we're going to start talking about angles and something called radian measure. And this topic, this lecture is going to be incredibly important as it kind of starts the foundation of our study of trigonometry. And so trig is going to be a big part of the course, obviously, and you gotta have a strong foundation from the beginning. So pay attention to all the important concepts and topics that we discuss in this lecture, and know that they're going to come up quite a bit in the coming lectures. Okay. Anyway, so what are we going to work through here? First off, we're going to recognize and use the vocabulary of angles. Then we're going to talk about degree measure. Then we're going to use radian measure. And then we're going to convert between degrees and radians. And then we're going to draw angles in standard position. So we're going to do some, drawing angles, freehand today. They're not going to be perfect. I don't want anyone to think the angles I draw are going to be perfect, but we'll do that. And then we're going to do two quick things. We're going to talk about coterminal angles, and then we're going to talk about how you find the length of a circular arc, or this will be, what I'll talk about at the end, something called arc length. Okay, so let's jump right into this. What exactly is an angle? So an angle is formed by two rays that have a common endpoint, okay? One ray is called the initial side, and the other ray is called the terminal side. Okay, so here's what's going on here. We have these two rays. So rays have a starting point and then go on forever. This right here is the common endpoint of the rays here. Okay, we can think of this as what's called the vertex. So this blue ray here is the initial side. This kind of red ray here, if you want to call it red, is called the terminal side. And we're going to denote this angle here. All right, in this case, we'll just call it angle theta. So we can call it angle ABC, or just theta. Okay, we're going to stick to the Greeks often in our lectures for these. Okay, if you had taken a geometry class, you would call it angle ABC. But here we're just going to say, okay, we have this angle, and this is the Greek letter theta. All right, so an angle is what's called in standard position. If it's vertex, okay, so that the endpoint where the two rays are joined. Okay, so if it's vertex, is at the origin of a rectangular coordinate system. All right, so we're going to do a lot of this, okay? I'm going to spend a lot of time talking about angles in standard position. So the angle is centered at the vertex of or the origin, excuse me. It's centered at the origin of the Cartesian plane, all right? And its initial side lies along the positive x-axis. Okay, so we're going to have our initial side here, okay? And then the angle, in this case, our angle alpha, will go all the way to this terminal ray here. Flip side here, you could have, this is going to be what's referred to, and you'll get to this on the next slide, but this is a positive angle. And then you'll notice here what happens is the angle opens downward here. Okay, so still centered at the origin, but opening downward. So this is called a negative angle. And that's okay to have positive, an angle be positive or an angle be negative. It just specifies the direction that it opens, okay? So going back here, right, going forward, I mean, so when we see an initial side and a terminal side in place, there are two kinds of rotations that can be generated, okay? So that positive angle is generated by a counterclockwise motion, okay? So this is going counterclockwise. This is that positive angle that I was talking about. All right, so this angle alpha here is positive. And negative angles are generated by a clockwise rotation. So this way, all right, and so we can see here that angle theta is negative. All right, so we positive angles open counterclockwise, negative angles open clockwise. All right, so measuring angles using degrees, this is something we're all used to seeing. When someone says a 45-degree angle or 90-degree angle, you should have an understanding of degrees, how you use degrees to find an angle. All right, so angles are measured by determining the amount of rotation from the initial side to the terminal side. Okay, so an angle in degree form is how long, what is the rotation here? Like this. All right, so a complete rotation of the circle is a 360-degree angle. So if we have an angle that goes like this, back around like this is a 360-degree angle. All right, so an acute angle is an angle that measures less than 90 degrees. That might be an angle that looks like this. Okay. A right angle measures 90 degrees. So something like this, and you'll commonly see that little symbol there to represent a right angle. An obtuse angle measures more than 90 degrees, but less than 180 degrees. So it might be something like this. Okay, let me go back like this. This is an obtuse angle, more than 90 degrees. And a straight angle measures 180 degrees, so it would look like this. Okay. What we're going to spend a lot of time talking about is this concept of measuring angles not in degrees like this. Okay, not with degrees, but with what's called radians. All right, so what is exactly is a radian? All right, an angle whose vertex is the center of a circle. So we're going to be talking about all this stuff in terms of circles, okay? Is called a central angle, okay? So we have this circle. That's a poorly drawn circle. Let me try to draw a better one here. It's tough, always tough to draw circles freehand, So we have this circle, okay? And its vertex here, all right, is the center of the circle. Okay, so vertex. The radian measure of any of the central angles, so a central angle is one whose center is a circle, okay? All right, a radian measure of any central angle of a circle is the length of the intercepted arc divided by the radius. Okay, so let me explain what the intercepted arc is. So here's our angle. Okay, angle is 2 rays, right? From here to here is the radius, okay? This is the intercepted arc right here, okay, between the 2 rays. So the intercepted arc is between the 2 rays. The 2 rays of the angle. Okay, so all you're going to do, all right, to determine a radian, okay, the radian measure of the angle. So the radian measure, you take the length of this intercepted arc and you just divide it by the radius of the circle, okay, and that's going to tell you what is the radian measure. And it doesn't matter, by the way. You would get the same thing if you had drawn the circle like this, okay, around the 2 rays. The radius would shrink and the length of the arc would shrink, but then this ratio would stay the same, okay? So 1 radian, okay, is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. So 1 radian is measured as, what is the radius of that circle? Well, this arc here has the same length. That's what is defined as 1 radian. Okay, because it would be length of arc, length of intercepted arc. Divided by the radius. Well, here what we're saying is, well, that length of the arc is the radius, so it would just be r divided by r would be 1. That is what signifies 1 radian. 1 radian. All right, so the way we're gonna calculate radian measures, okay, just the formula we'll use. So consider an arc of length s on a circle of radius r, okay? So you can see that going on over here, okay, in this drawing right here. All right, we have this arc here. All right, that's the intercepted arc. All right, the measure of a central angle theta, so a little bit of a theta, that intercepts the arc. So the measure of this angle here, okay, in radians. You're just going to take the length of S, that intercepted arc, and divide it by R, okay, and then you're going to tack on radians, okay. So you'll see me often, sometimes I'm just going to write it like this. I'll write rads instead of radians, or some, you know, I'll just put rad sometimes. All right, so let's talk about how you find, how you find the measure of an angle in radians. Okay, I'll give you an example here. Okay, so a central angle theta, okay, in a circle of radius 12 intercepts an arc of 42 feet. Okay, what is the radian measure of this angle theta? All right, let me try to draw it so you can see what's going on here. Okay, so we have this circle. Oof, really bad drawing with these circles, forgive me. So we have this circle, okay, and what we're saying here is the radius of this circle is 12 feet. So then what we have next here is I say, okay, we have this intercepted arc, okay, intercepted arc of 42 feet. So it might be something that looks like this. So I have this ray here, okay, and this arc here equals 42 feet. So I'm saying, well, what is the measure of this angle theta here? All right, well, theta is equal to S divided by R radians. All right, so the angle theta would be, you would take the length of the arc, which is 42 feet, divided by the radius, which is 12 feet, okay, and then radians. Well, look what happens here. Feet cancel, okay? And then, what is 42 divided by 12? That just gets you 3.5 radians. And that's how we would define this, okay? And my measurements, my angle here might not be exactly right, but yeah, you get the rough idea here, okay? So that's it. That's just it. That angle is 3.5 radians. So whatever degree that is, okay. We'll talk about how you figure out once you have radians. We'll actually do that next. How you can switch between radians and angles and so on. Okay, so this is the conversion between degrees and radians. I think I might have said in the previous between angles and radians. Sorry about that. I meant degrees. How you switch between degrees and radians. All right. So using the basic relationship, this is what we're going to do here. Pi radians is equal to 180 degrees. Okay. So also note that 2 pi radians is 360 degrees. Okay. So that would be that full circle rotation. So what does a 180 degree angle look like? It looks like a straight angle. Okay, so this is 180 degrees, or also pi radians. Okay, that's the same way to say the angle here. So to convert degrees to radians, all you're going to do is multiply the degrees by pi radians over 180 degrees. Okay, and then to convert radians to degrees, you're going to multiply the radians by 180 degrees divided by pi radians. Okay, and let me load up. I should have done this. Let me load up my calculator here, so we'll have that handy. Okay. So let's use these here to practice some problems. So converting first degrees to radians, and then we'll convert radians to degrees. Okay. All right, so let's convert each of the following angles to radians. So we'll start with this. Let's take a 60-degree angle. All right, how many radians is that? All right, so all you're going to do is you're going to take the 60 degrees and multiply it by pi radians divided by 180. 180 degrees. So 60 degrees times pi radians over 180 degrees. Well, what happens? The degrees cancel, okay? So then you're just left with 60 times pi, or 60 pi, divided by 180 times, and the unit of measure here is now radians. Well, what does 60 divided by 180 become? That just becomes 1/3. So this is just pi over 3 radians. So a 60-degree angle is equivalently written as pi over 3 radians. Let's try this one. Let's look at 270 degrees. All right, so I want to write that in radians. So 270 degrees, all you're going to do is always multiply it by pi radians over 180 degrees. Well, the degrees cancel, okay? And then you're left with 270 pi over 180 radians. Well, look, 90 goes into 270 3 times and 180 twice. So this just becomes 3 pi over 2 radians. And look, you can even do something like this. Okay, let's take a 37-degree angle. Okay. So notice how these worked out nice and neat. But if it doesn't, that's okay. So just going to take 37 degrees times pi radians over 180 degrees. So these are going to cancel, right? Right, degrees, degrees. So all you have to do then is take, well, what is 37 divided by 180? And look, I'll go out 3 decimal places. So this is 0.206 when I round it. And then don't forget you have pi radians. Okay, so this was rounded to 3 decimal places. Okay, so we're doing it. Now let's go radians to degrees. Okay, so the trick with radians to degrees is you're going to flip it. You're going to multiply by 180 degrees over pi radians. So like, let's go back. Let's figure out what 3.5 radians was, okay, in terms of degrees. Okay, so you're going to multiply, going back, 180 divided by pi radians. Well, look what cancels, right? Radians, radians. And so you're left with 3.5 times 180 divided by pi degrees. So just grab your trusty calculator for this, right? So you're just going to go 3.5 times 180 and then divide that by pi, which is right here. So, I'm sorry, 630 divided by pi. Look, this is roughly a 200, and I'll round it to 3 decimal points, 200.535 degree angle. And again, rounded to 3 decimal. So going back here, you know, basically I drew this angle wrong, just so we're clear. It would have looked really like this. But that's roughly what it would look like in reality. Okay, anyways, let's just do another one here. Let's convert this one. Let's look at 4/3 pi radians. And I want to convert that to degrees. So look, again, you're just going to do 180 degrees divided by pi radians. Well, look, what's going to cancel out? This is awesome here. Radians cancels out. Pi cancels out. And so you're just left with 4/3 times 180 degrees. Right, so like, you know, what happens here, right? 3 makes this 60, right? And then 4 times 60 gets me, it's a 240 degree angle. All right, let's try this last one here, okay? Let's look at minus pi over 2 radians. All right, so let's change that to degrees. So you're going to multiply by 180 degrees over pi radians. Well, look, this one's easy, right? Don't forget you have the negative sign. And remember, it's okay to have a negative angle. So pi cancels. Radians cancels. And you're left with negative 180 degrees divided by 2, which is, this is just a negative 90 degree angle. All right. All right, so now let's talk about how we kind of have an understanding of, you know, the relationship between degree and radians, what exactly a radian is. Now let's talk about how you just sketch some angles, right, that are given to you in radians, so you have some understanding of that. Okay, so the below figure here illustrates that when the terminal side makes one full revolution, it forms an angle whose radian measure is 2 pi, okay? So right here, one full revolution around a circle here gets you 2 pi radians, okay? So then you can see here, all right, looking at the quadrantals here, all right, angles are formed by 3/4, 1/2, and 1/4 of a revolution. So to go from here, okay, like this, all right, this gets you, this is 3/4 of a revolution of the circle, okay? So that is, the way you measure that is, it would be 3 pi over 2 radians, okay? A half rotation, like this, whoop, okay? That's a 180 degree angle, which we said was pi radians. And then look, this one right here, a quarter revolution, this is just pi over 2 radians. Okay, so a 90 degree angle is the same thing as pi over 2 radians. All right, so let's use these, okay? And some tricks to help us sketch some angles, okay? And it's gonna be fun, and you're gonna have to pay attention to the tricks I use to figure this out, okay? All right, so let's draw and label the angle in standard position. So we have this angle that we're gonna call alpha, okay? And it's 3/4 pi radians. Okay. All right, so that's the angle measure of it. All right. Okay, so here's one thing you should be able to see. Well, that is definitely 3/4 is less than 3/4 pi radians is less than pi radians, but it's greater than pi over 2 radians. Okay, so here's the trick. What you have to do. Okay. First off, I notice it's a positive angle. And so what you want to write is, you want to rewrite this so that when I multiply it by 2 pi, I get back to 3 pi over 4. Okay? So, you know, what do you have to multiply 2 pi by to get 3 pi over 4? So you would actually multiply it by 3/8. Okay, so what this tells me, okay, is this tells me that this angle is 3/8 of a rotation. Okay, so here's X, here's Y. What is 3/8 of a rotation, right? Well, think about it like this, okay? This would be, so what we're saying is a full rotation would be the same thing as 8/8. Okay, so this would be 2/8. This would be 4/8. So 3/8 would have to be right here. Okay, so what I'm saying here is this, all right, is my angle alpha right there. All right, so it went, and so in terms of eighths of a rotation, right? 8/8 would be one rotation. So that would be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So that's how I did it. You can also, if it helps, right? You can convert this just to degrees, right? If need be, okay. So if I take 3 pi over 4 radians, and I multiply this by 180 degrees over pi radians. Pi cancels, rads cancel. So take 3 times 180 divided by 4. And I'm saying this is a 135 degree angle, which falls right between 90 and 180. So this is, another way to do it. All right, it definitely can be confusing, so let me try another one here, okay, to show you here. All right, so I have this one, okay? My angle is negative pi over 4 radians. Okay, so first off, I know it's a negative angle. Okay, so let's use the trick. Okay, so what do 2/4? 2/4. So what do I have to multiply this by? Okay, what do I have to multiply 2 pi by to get negative pi over 4? Well, think about it, right? So you have to multiply this by, what number? Okay, you have to multiply by negative 1/8. So what this means is here you went 3/8 of a rotation. Now you're going negative 1/8 of a rotation. So remember, okay, and you're going down here. So this would be negative 8/8. So you're only going 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So negative 1/8 would go right to here. And you would see that, right? Like if you convert this to degrees, all right, this is also a negative 45 degree angle. All right, let's do another one. So what I encourage you to do actually is take this one here and try it on your own, right? See if you can do this, okay? So it's a little bit tricky. So again, this is a negative angle. All right, I'm going to be quiet for a second and see if you can, if you need to pause the video, give it a shot, and then unpause the video, and then I'll come back and show you what I get. All right, so hopefully you gave it a shot, or if you just want to see me do this, okay? So the trick was, okay, what do I have to multiply 2 pi by to get negative 7 pi over 4, right? So you have to multiply by negative 7/8, right? Because then the 2 would make that a 4. Boom. Okay. So what this means is I'm negative 7/8 rotations. So again, you're going negative 7/8. So negative 7/8 goes like this. Okay, so that's my angle beta here. All right, let's try the last one. Okay, I know it's confusing, so let's try another one. All right, so this one, 13 pi over 4. Okay, so this is tricky. So this is in radians. Okay, so I've got gamma, so my angle gamma here. Really poorly drawn Greek letter there. All right, what do I have to multiply by 2 pi, okay, to get 13 pi over 4, right? So that's, that's the trick, right? So you have to get, you would actually have to multiply this by 13/8. Okay? So what that means is this is 13/8 of a rotation. So that's 8 over 8 plus 5 over 8. Okay, so think about what that is. That's one full rotation and then another part of a full rotation. Okay, so one full rotation and then more. Okay, so watch how I do this, okay? This is going over, okay? Over. This is 8/8 of a rotation. Then 1, 2, 3, 4. Here. It went around and then boom, back again. So it's a crazy rotation, okay? So this here is the angle gamma, 13 pi over 4 radians. So it's more, it went all the way around once and then boom, back to there, another 5/8 of a rotation. All right. I highly encourage you next is to always keep this one handy. Trust me when I say this photo here will be incredibly helpful, as we go through the course. So what it has some common degrees listed, common angles listed in both degrees and radians. Okay, so like this one here has positive angles. So a 30-degree angle is the same thing as pi over 6 radians, and you can keep going. I won't go through all of them. Like a 150-degree angle is the same thing as 5 pi over 6 radians. And then you have the flip side here with the corresponding negatives, okay? Please print this out and have it handy, okay? This is a very important table. It's very helpful, okay? All right, now let's talk about something called coterminal angles. So two angles with the same initial and terminal sides, but possibly different rotations, are called coterminal angles. Let me give you an example here, okay? Just going back here, let's use this 150-degree angle here, okay? So this angle we'll say is 150 degrees. okay, which is also 5 pi over 6 radians. A coterminal angle, if you look back here, okay, going on the other side, is the same thing as a minus 210 degree angle, or minus 7 pi over 6 radians. Okay, these are called coterminal angles. Okay, they have the same initial side, same terminal side, just one is a positive angle, you know, one is a negative angle. So they have different rotations. Okay. And so what I want to show you how to do on the next slide is how to find coterminal angles. All right, so increasing or decreasing the degree measure of an angle in standard position by an integer multiple of 360 degrees. So literally just by adding or subtracting 360 degrees, which is the same thing as 2 pi, all right, results in a coterminal angle. All right, so thus an angle theta degrees is coterminal with angles of theta degrees plus or minus 360k, where k is an integer. And if you have it in radian measure, okay, same thing. So increasing or decreasing the radian measure of an angle by an integer multiple of 2 pi results in a coterminal angle. Okay. So thus the angle of theta radians is coterminal with an angle of theta plus 2 pi over k radians, where k is an integer. All right, I'm just going to show you some examples of how to switch and how you find coterminals here. All right, so let's assume the following angles are in standard position. Find a positive angle less than 360 degrees that is coterminal with each of the following. So look, if you take a 400 degree angle, coterminal here, remember you can just add or subtract 360 degrees to get a coterminal angle. So this, just take 400 degrees minus 360 degrees. What I'm saying here is a 40 degree angle is the same thing as a, is not the same thing, excuse me, is coterminal with a 400 degree angle. Here, if you take minus 135 degrees, and look, let's just add 360 degrees, okay? When you add those together, you get 225 degrees. This angle here, 225 degree angle, is coterminal with a 135 degree angle. Let's try it in radians. Okay? So assume the following angles are in standard position. Find a positive angle less than 2 pi that is coterminal with each of the following. So 13 pi over 5. So all you're going to do here is you're going to subtract 2 pi. So you just have to, common denominator here. And so an angle of 3 pi over 5 radians is coterminal with an angle of 13 pi over 5 radians. And same deal here, negative pi over 5 radians. So hopefully you can see the pattern here. Negative pi over 15, excuse me. I'm going to add 2 pi. So common denominator, I'm going to make this 30 pi over 15. And you can just see that this just ends up being 29 pi over 15 radians is coterminal with minus pi over 15 radians. All right, let's end with just a real quick example talking about how you find arc length, okay? So we know that radians, the formula for radians is pi is equal to S over R. Well, if you want to find just the arc length, just multiply R over, okay? So the length intercepted by the central angle, theta here, so arc length here, is given by S. The length of that arc is equal to the radius times theta, as long as theta is in terms of radian measure, okay? Okay. All right, so let's try one problem here. A circle has a radius of 6 inches. Okay, so here's the circle. Okay, it has a radius of 6 inches. Find the length of an arc intercepted by a central angle of 45 degrees. Okay, so here's 45 degrees. I want to find this length here. All right, so the first thing you need to do is you need to convert, remember the formula, S is equal to R times theta. You need to convert it in terms of radians, okay? So you're just going to multiply this by pi radians over 180 degrees. Cancel, and the degrees cancel out here. So you're, 45 divided by 180 is 1/4. So this is just pi over 4 radians. So then S is equal to R times theta. Okay. So R here, R is the radius, it would be 6 inches. And then you're just going to multiply this by pi over 4. Okay. So find the exact answer first. So we're going to express it in terms of pi. So this would be 6 pi over 4, which would be 3 pi over 2 inches. And then going to 2 decimal places, here you're just going to need your calculator. So this would be 3 times pi divided by 2. And going to 2 decimal places would be 4.71 inches. All right, class. I know there was a lot to cover in this lecture, and you're going to get a chance to practice it. But if you have any questions, as always, please let me know.